Okay, let's get going on perfect gas laws. We are going to talk about Boyle's Law, Charles' Law, Gay-Lussac's Law. Remember, I am going to be talking faster than you can write. And remember to look at your Google Doc to find out what exactly you need to have in your notes. Okay, here we go. Boyle's Law, the volume of a gas at constant temperature varies inversely with the pressure exerted on it. Basically, pressure goes up, then volume goes down, or pressure goes down and volume goes up. So imagine if I had a sealed can of air, like a Coke can. I drank all the Coke and I sealed it up, and it just had air in it. And I drop it in the ocean, and let's pretend it started to sink. Um, and as it starts to sink, the pressure is going to go up. So the pressure like around it, like that swimming pool example from the last video. So we have pressure as we go deeper in the ocean. So the volume of the can is going to get smaller. So that can is eventually going to crush. If you look at this little animation, same type thing. If we have this container that has some weight on it, the little green weights that stack up, it's just illustrating that air is compressible. Or gases are compressible. So that's Boyle's law. Our equation is P1 V1, P1 times V1 equals P2 times V2. The ones and twos kind of stand for a before situation over here, one, and an after situation over here. And of course, if there's no multiplication symbol, any two variables next together in math, that just automatically means multiply. Okie dokie, let's read through this. A cylinder is filled with 40 cubic inches of air at gauge pressure of 60 psi. The cylinder is compressed to 10 cubic inches. What is the resulting absolute pressure? So what I love to do with these is I write down what I know and what I don't know, including all of my units. My initial pressure was 60 psi, or 60 pounds per square inch. My final pressure, look, what is the resulting absolute pressure? I don't know that, so question mark. My original volume, or my V1, clearly says it was 40 cubic inches, and my resulting volume was 10 cubic inches. Here's a little picture of what we have going on. Basically, we are pushing this plunger down. We have a certain starting pressure. We have a certain starting volume. We have an ending volume. We don't know what the ending pressure is. That's what we want to find out. Convert to absolute pressure. We talked about that in the last video. So we're going to take that P1, that 60 psi, add 14.7, and get 74.7 pounds per square inch, or 74.7 psi. It is important to know that this 74.7 is what you're going to use with the math that we're about to do. You could even scratch this out, put a little line through it, and replace it with the 74.7. It's important not to use this initial gauge pressure in your math. That's why we had to convert it. Okay, here's our equation. P1 times V1 equals P2 times V2. P1 is 74.7 pounds per square inch times 40 cubic inches, which is my V1, equals P2, which is our unknown, times 10 cubic inches. I want you to notice that I kept all of my units. That's important. You'll see that throughout these three perfect gas laws. And I'll show you how they cancel to get our final units. We multiply 74.7 times 40, we get 2,988. I didn't do anything with the units. We have pounds per square inch times cubic inches, equals nothing happened on this side. Notice it's the same. We're trying to isolate P2, or get P2 by itself. We divide both sides by 10, so that's going to get rid of 10 cubic inches on this side. And here I'm showing dividing by 10 cubic inches. Let's talk units before we get to the final answer. Look what happens. Cubic inches cancel, and we're left with pounds per square inch. Our final answer, 298.8 pounds per square inch, or PSI. All right, Charles' law. Volume of gas increases or decreases as the temperature increases or decreases, provided the amount of gas and pressure remain constant. Okay, best example is a hot air balloon. We're going to increase the temperature of the air inside that balloon, and the balloon is going to increase its volume. That's how a hot air balloon works, right? So all of that remains the same as long as we don't change the amount of pressure or the amount of gas inside of it. You can see our little animation. You can see our little graph. Temperature up, temperature down, volume down. And our equation is V1 divided by T1 equals V2 divided by T2. Let's jump in. A balloon is filled with 28 cubic inches of air and is in the freezer where the temperature is 32 degrees Fahrenheit. The balloon is carefully placed in the oven that is 200 degrees Fahrenheit. We assume it's not going to pop. I'm just trying to illustrate a point that we're changing temperature. What is the resulting volume? Again, let's put our knowns and unknowns. Volume 1, 28 cubic inches. Volume 2, I don't know. Temperature 1, 32 degrees Fahrenheit. Temperature 2, 200 degrees Fahrenheit. Easy. Convert. I see Fahrenheit, so that means I have to convert to Rankine. Add 460 to each. My new temperatures are 492 and 660. Again, if I were you, I'd put a little line through this and then write 492, little line through this one, and write 660 degrees Rankine. Do not use these original values in your math. All right, there's our formula, just like we talked about. Let's fill in what we know. Volume 1, 28 cubic inches. Temperature 1, 492 degrees Rankine equals volume 2, which we don't know, and temperature 2, 660 degrees Rankine. Cross multiply. I like to do the unknown variable side first, right here. So V2 times 492R is 492 degrees Rankine times V2. That's pretty straightforward. Equals 28 times 660, 18,480. And I keep my units. It's important that we keep our units. 18,480 cubic inches times degree Rankine. And we are trying to isolate V2. The way we isolate V2 in this particular situation, it's being multiplied by 492. So we divide by 492. Divide each side by 492. 492 degrees Rankine completely cancels with this side. That's why we're left with V2. And then we divide 18,480 divided by 492. We're left with 37,560. Let's talk about units. Degrees Rankine cancels. That's why we're left with cubic inches. 37.560. Last one, Gay-Lussac's law. Absolute pressure of a gas increases or decreases as the temperature increases or decreases, provided that the amount of gas and volume remain constant. My example, Coke can in a hot car. So here's that can full of Coke. We leave it in a hot car, super hot day. As the temperature increases in that car, the pressure is going to increase in that car, and that might burst that can. And then the opposite, temperature down, pressure down. Our equation, P1 over T1 equals P2 divided by T2, or P2 over T2. Here we go. All right. So let's read. 300 cubic inch sealed air tank is sitting outside. In the morning, the temperature inside the tank is 62 degrees Fahrenheit. Gauge pressure is 120 psi. By afternoon, the temperature inside the tank is expected to be close to 90 degrees Fahrenheit. What will the absolute pressure be at that point? Really easy. Here's what we know. 300 cubic inches for volume 1 and 120 for our pressure 1. Temperature 1, 62. Temperature 2, 90 degrees Fahrenheit. And our pressure 2, we don't know. Look at the last sentence. What will the absolute pressure be? Pressure 2, we don't know. So if you're wondering why we have 5 different variables or 5 different things, but only 4 go into our equation. I want to point out that this is an example where you don't always need the information, and it's important for you to realize what you're trying to solve. I'm trying to solve for P2, and I have P1, and I have these other 2 temperatures. I don't need volume. It's just useless information. Sometimes these word type problems, they're like that. All right, first thing, let's see, convert pressure to absolute pressure, 120 plus 14.7, 134.7. I would mark that off right here and write in 134.7. Do not use 120 in your math. And convert our 2 temperatures. We get 522 and 550. Same thing, cross that out and change it in your equation so you don't accidentally use 62 and 90 in your math. P1 over T1 equals P2 over T2. P1 right here over T1 right here equals P2, don't know it, divided by T2 550. Really simple at this point, cross multiply. I love to start with the unknown variable. I like to keep that on the left, keeps things nice and neat. P2 times 522 degrees Rankine equals 522 degrees Rankine times P2 equals 134.7 times 550. I get 74,085. Bring your units with you. Pounds per square inch times degrees Rankine. Trying to solve for P2 or isolate it. It's being multiplied by 522, so we divide by 522. 522 degrees Rankine, all of that cancels. We're just left with P2. Divide the other side by 522. And let's talk units before we do our answer. Notice that degrees Rankine cancels. Our units are going to be in PSI or pounds per square inch. It's the same thing. 74,085 divided by 522 is 141.925 PSI.